Hello and welcome to my channel. My name is Mohammed and today I'm going to show you the Android 15 improvement in performance and battery efficiency. First, I would like to introduce the areas that improvement happened. There are four main areas in Android 15 that we can mention as a good improvement. The first one is app startup, the second one is app storage, profiling, and SQLite. But let's see how these areas introduce some improvement in sense of performance in Android 15. ApplicationStartInfo is a new class introduced in Android 15, providing lots of APIs, helping us to have a deeper insight into application startup performance. Having more information about an application, especially in startup time, would be very helpful for diagnostic purposes. For example, get a startup timestamps return a map object including two parameters, an integer value which is kind of proceeding states and a long value which is a timestamp. And this map object includes lots of information about each state of application startup. One key advantage of this class is that it allows us to retrieve historical data on the most recent application launches, both during and after the application's startup. The only thing we need to do is to call getHistoricalProcessStartReasons to receive a list of ApplicationStartInfo objects. For your information, this method has one input parameter which you can set the maximum number of results you are willing to receive. If you set it 0, it will return all the information it has. Here I have listed out all the public methods of ApplicationStartInfo class that you can see at once, and if you wanna dig into that, you can check out on yourself the Google documentation. Now that's the time to check the improvement in app storage utility, which is a StorageStats class. GetAppBytes by data type is a new method in StorageStats, providing new insights into app storage usage. As you can see from the method footprint, you will feed the data type that you are interested to have insight into that, and then the method will return some information about that which is in line format. This method helps you to understand how the app using all the spaces like file splits, AUTN speedup related code, libraries, DEX metadata, and guided profiles. The next improvement in Android 15 is ProfilingManager class, which helps you to collect lots of information, actually profiling information from within your application, such as heap profiles, stack sampling, heap dumps, etc. It provides a callback to your application with some tags to identify the output file. One of the advantages of this new class is that it lets the system to be triggered on the behalf of the app to start and stop profiling programmatically. So that's very nice that in your application, in some events, you can start or stop profiling. It can stop by events, or there could be a timeout that stops the profiling process. I would like to see that how it works, so most probably I will provide some new videos about this profiling new features in Android 15 as a kind of hands-on code to see that how they work in a real application. Again, I have listed out the public methods of ProfilingManager class that you can see here. At least we have like 6 methods in Android 15. It might be more in Android 16. Okay, we can wait to see that how it can be improved or how it works in reality. So you can dig into that and check the Google documentation on. Based on the Android 15 documentation, the next improvement is in SQLite database area that they have tried to expose advanced features from underlying SQLite engine, that they target specific performance issues that can manifest in apps. For example, when you are fetching some information from the tables, so it's kind of like read-only commands or execution. So they have provided some new methods in SQLite, which is in version 3.44.3 as a read-only deferred transaction, begin transaction read-only, and begin transaction with the listener read-only to issue read-only deferred transactions. The next method that I can mention here are some functions relating to row counts and ID. The two new methods are get last change row count and get last insert row ID. So they are so helpful when you are inserting something into the table and you would like to know that the row ID or maybe the last change row count. So I think all of them are so helpful, especially when it comes to the performance of the SQLite and you are working with lots of records in your database. The interesting point about read-only deferred transaction, which I can see in Google Documents, is that they mentioned that this kind of transaction could run concurrently with each other, especially if the database is in WL mode, so they can concurrently run with immediate or exclusive transaction. And as you might know, WL is write-ahead logging algorithm, which guarantees that no data modification are written to disk before the associated log record is written to the disk. So that's kind of, maybe I would say, that important improvement. The last point that we'll discuss here is about ADPF. ADPF actually is Android Dynamic Performance Framework. In Android 15, some new APIs have been introduced, allowing us to interact more directly with power and thermal systems. So it's important, especially for kind of high performance or maybe the game applications that they are using CPU a lot. So it can hit the device and using lots of power, and they can control how, or maybe monitor how they are using the battery and how the power and the thermal are going to cooperate together. So as a game player, maybe you want to stop if it's so heated. And the next improvement is in power efficiency mode for long running background workloads, that a thread can say that, okay, I prefer to be long running background thread, and in that case it means that it prefer to be a power saving over performance. It's a new mode for a thread or an application, which helps to run in the background and not be as a high performance. Just as an example, for the new APIs that you can interact with power and thermal system, actually the GPU and CPU workload could be somehow adjusted. It means that the system could adjust the CPU and GPU frequency together to meet the workload demands in the best case and in the best form that it can work. So maybe you have less workload, so you can reduce the frequency. It means that the heating process won't be continued, and also you can save lots of power because of reducing the frequency based on your workload. Thank you for watching, and see you in the next video. If you like this video, please hit the like button and don't forget to subscribe. See you soon.